This question is on the topic of chemical bonding. In this question, we're supposed to find out the correct structure for the compound hydrogen peroxide. And hydrogen peroxide has the following chemical formula, H2O2. So we're given 4 options where there are different arrangements of oxygen and hydrogen atoms, and we're supposed to determine which one is the correct one. So the most straightforward method is to recognize that each line in the structure represents a covalent bond, and each covalent bond represents a shared pair of electrons. So what we can do is that we can, based on the structure given, draw out the dot and cross diagram for each option. For example, for option D, the dot and cross diagram as shown would look something like this. Alright. So after drawing out the dot and cross for all 4 options, we need to determine which one is it after sharing electrons. Do all the atoms have fully filled valence shells? That is the most straightforward method. However, for this question, there is a shortcut that you can use. And to use the shortcut, you need to recognize the relation between the maximum number of bonds an atom can form to the group number. Okay, so the maximum number of bonds that an atom can form is related to the group number in this way. For atoms in groups 1 to 4, the maximum number of bonds that it can form is equal to the group number. For atoms in groups 5 to 7, the maximum number of bonds that it can form is 8 minus the group number. So for example, hydrogen is in group 1. So the maximum number of bonds that it can form is 1. Carbon is in group 4. So the maximum number of bonds that it can form is 4. Oxygen is in group 6. So the maximum number of bonds that it can form would be 8 minus 6, which is 2. Chlorine is in group 7. So the maximum number of bonds that it can form is 8 minus 7, which is 1. Now that we have learned that the maximum number of bonds is related to the group number, let us go back to the question. We have already established that hydrogen can form a maximum of 1 bond, and oxygen atoms can form a maximum of 2 bonds. So if we were to look at option A, and we look at this hydrogen atom over here, you would notice that this hydrogen atom has formed 2 bonds, and that's not possible because hydrogen can only form a maximum of 1 bond. Same for option D. If you look at this hydrogen atom, it has formed 2 bonds, so that is not possible. And then if we look at option C, this oxygen atom has formed 3 bonds, which again is not possible because oxygen can only form a maximum of 2 bonds. So by recognizing this concept, it will allow you to determine the answer very, very easily by eliminating the wrong structures.